Hello, and welcome to the first stream of Project Longshot. So today we'll be starting essentially. For those of you who don't know what Longshot is all about, I've linked to a small YouTube clip that explains it. So essentially, we're gonna be doing a voxel-based survival game. We're gonna be doing it in C++, compiling that to JavaScript so we can run it in our browser. The goal today is to get sort of a basic display up and running. Yeah, let's get started. So, Emscripten, which is sort of the compiler we're using, has the wonderful task that it sort of implements an interface called EGL, which allows us to get the display and get a WebGL context set up. So the first thing we need to do is initialize EGL. So yeah. Luckily, there's this wonderful little thing called an EGL API quick reference card, which will help us with most of this stuff, but we're gonna start by creating a small little class to contain all of this, which we will call EGL display. So we are gonna give this a constructor here and a destructor, at least as an initial go. So let's see what we can do with that. I'm going to start with this constructor. Now, the first thing we need to do for EGL is we need to get a display reference. And we do this first by including EGL header, which is EGL/EGL.h. Then we can call EGL get display. Now, there's a native display type, and for Emscripten this is simply 0. There's only one display, the current canvas on the website, or on the web page, so that's all we need. Now this returns us some weird thing, probably something like an EGL int or something like that. An EGL display. So this we're gonna want to store for later. And we're gonna need to include. My spelling today is a little bit terrible. Gonna want to include the EGL header here as well, so that we have that reference. So we are gonna save the returned display here. And once we have the display, we can actually initialize EGL using EGL initialize, giving it the display. And then it will tell us major and minor versions of EGL. So it does this by reference, so we're going to save a major and a minor version here and pass these in. Hello, Regulus. Glad you could join us. So that should do the sort of essential, we don't need that anymore as it's included in the header file. Should sort of do the main initialization of EGL. Declare the constructor to get that out of the way so it exists. Then we are gonna, let's just start by something simple. We're gonna output the EGL version. which is major, minor. Get the IO streams include in, so that we can actually do this. There we go. Then we're going to go over to our main function here. We are going to include the EGL display here. And then we are going to instantiate an EGL display. So hopefully that should compile. Yeah, that much worked. So if we reload the page here, and I'll just let you guys see as well here, you can see we're now getting an EGL version of 1.4 out. So we've managed to initialize EGL. Now let's just, not quite yet, be a little while before I finish the game. So we have an EGL display running. Next is to find a valid configuration so that we can initialize OpenGL yes, or WebGL in this case, on top of that. So we need to enumerate the configurations for EGL. This is done through an EGL get configs parameter here, which we give it the display. Then we give it a buffer of configurations, which we'll create in a moment. Then the size of set configurations array, which will be the size of configs. Surprise, surprise. And finally, the output number of configurations, which we will save in a numconfigs variable. So we need to create our configs array. Here we'll give it 16 configs just to do something. And then we need to store the outcoming number of configs here. So this gives us all the configurations available. We can just print out that. So we output the number of configs here. We can just try running that again. And we are told that there is one EGL configuration. Right. Emscripten is a little bit limited. It only has one. If you run this on a desktop or some other platform, you'll get most likely a lot more. So let's enumerate these configs. So if we step through these one at a time, we can grab some data about them. We can, for example, has this wonderful EGL get config attribute, and we'll just take a look at the wonderful reference here. Just give you guys a look as well. You can see there's quite a few different attributes we can get. Some of the interesting are like the red, green, blue sizes. Things like the depth size, transparent type, transparent or the number of samples, sample buffers. But I think we'll just grab the red, green, blue size and just print those for the first little while. So to grab those, what we do is we do the get config attrib here. Let's see if we can just get it to do what I want it to. So the first parameter is again the display. then we need to give it the config that we're looking at. So we index our config array here. Then the attribute, which is EGL red size, for example, and then a place to write it out. So we're just going to have a variable called r. So this is an EGL integer. We're going to have for red, green, and blue. And then we're just going to do that a couple of times. Red, green, blue. And we of course have to change the attribute we're getting. And then we can output a little bit about it. So this should give us the red, green, and blue configuration of each of the different, of each of configurations, of which we have one. So you can see, you guys see it again? The EGL configuration has red, green, and blue channels of 8 bits each, which is very usual. So now we're gonna grab a context. We're gonna choose a config. We're just gonna use the first one because I'm a little bit lazy right now. So we're gonna use an EGL config, which is gonna be a 0th config. I'm gonna leave a little note for myself. If we're doing this for like not WebGL, for like a desktop or mobile, you're going to want to walk through this list and pick sort of the config that's best based on what you want. But we only have one here, so that one will do. Now, from here, we are gonna go and at this point, normally for EGL, you'd create a window, or the native window. But again, this is WebGL, we don't need to do that. There's already a window for us and already a canvas for us. Instead, we just skip straight ahead and we create an EGL surface, which is what we're actually going to be drawing to. So this is our surface. We do EGL, create window surface, and we give it the display. We give it the config we want. Then we have a native window type. This is where you give the window that you're using, so that it knows what to work against. Here we just say 0. And then you can give it a list of attributes, or you can just say null pointer. And it'll use some sane defaults. We might come back to that later. From here, we're gonna create a context, an OpenGL or GLES context on top of that. For that, we need to specify some attributes on that. We need to tell what API we wish to use. So we create some attributes for our context here. And what we want to do is we want to have the EGL context client version set to 2. That will enable us to use GLES 2, which is what WebGL is based on. And that is also, we just terminate that list with an EGL none. And then we should be able to grab the context here. So we create a context with EGL create context. Again, display. This is going to be really, really common. Then we need to give it the config. For some reason, it's not telling me a lot of stuff about this. So we can tell other contexts we'd like to share with. we're not going to be sharing with any other context. And then we can give it the attributes we want. I have a typo in my title. You mean the missing E in game? Fixed. Now we actually have an EGL context, and we can do WebGL rendering with that. So we'll just quickly check that that works. Well, I'm not getting any errors, so I'm assuming it works. So, GL in general has this wonderful thing that's kind of a stateful thing. So what you do is when you want to draw to something, you make a given context current. So what we want to do is we want to expose an interface called makeCurrent, which we'll just void here. Exactly, it compiles, it works. We want to save our EGL context here for later reference. So let's just save that out here. And we have a makeCurrent that we want to implement here. So the way we do this is actually relatively simple. We call EGL makeCurrent, we give it the display. I can see it also wants the surface. So we're also going to go surface, going to save that in a moment. Just have a look at the reference for rendering surfaces, configuration management, rendering context, EGL makeCurrent. So there's a drawing surface, a reading surface, and the context. So we're going to be drawing and reading from the same surface. And then we're going to use the context for that. So I just need to move this surface out here. And then we're going to go for this surface here. And we'll give it another compile. Yay, it compiles. The program name I was using, that I'm using, this is CLine, which is an editor by, I forget what they're called, JetBrains. It's probably the best C++ IDE I've tried, and I've tried a couple by now. At some point you'll probably hear me saying I hate this, but that's the way it goes. Anyways, let's give this a go. If we try and make that display current, we should, in theory, be able to start doing a little bit of OpenGL or GLES. Just gonna give this a really quick test here. So if everything goes to plan, I should be able to include GLES2, GL2, GL2, better. And if everything's working, I should be able to set the GL clear color to, let's just color it red, because everybody loves red. And then I should be able to clear the entire spread. We're going to clear the color buffer. So if everything works, we should now get a nice red screen here when I refresh. Yay! So we've got WebGL running. Next thing is we're going to try and draw triangles. This is about how far I know what to do. You might have noticed that didn't take too long. From now on, it's going to be a little bit more guesswork. So we're going to create a new class, GLES renderer, to call it something. And from here, we are going to do, we're gonna, again, need to just declare this public. We need constructor, destructor, and we're just gonna have a single little function render here. So with the how I can use C++ for HTML, what I'm doing is I have a C++ compiler installed that's called Emscripten, which compiles C++ to JavaScript, which is then run in the browser. It's a kind of neat little trick. So I've got it declared here that I'm using the Emscripten archiver, C and C++ compiler, and for that reason my executables have a .js file extension because they end up being JavaScript. It generates really, really horrible looking JavaScript, which is something like this. This is sort of the nice part where it's just the preamble. Then somewhere down here, you get into sort of where my code appears, which ends up looking kind of like this. So this is like the standard time get, some sort of month name, I think, and then a lot of this is just like essentially assembly code translated to JavaScript, which kind of luckily for us, the JavaScript interpreters and JIT compilers in the browser are pretty good at turning back into pretty good assembly. So you don't actually use that much performance going this way. I hope that sort of answers the question. We were coming from the GLES renderer here. So we want to create the constructor. We want a destructor. And then we want a render function. So what we are gonna do is we're gonna assume when the constructor is called that we have a valid context. So that means at this point we can initialize textures and everything we kind of need to load in. Shaders, whatever. Then and again in render we're gonna assume that we have a context set up. So just to make that sort of clear, what we're gonna do is we're gonna, like here, we create the display, we make it current. Then we're gonna include the GLES renderer here. We're gonna create GLES renderer, and then essentially we're gonna go into an infinite loop here. At least that's sort of the theory. For now, we're not gonna go into an infinite loop. Actually, this is kind of an older way of doing it. I started to like this approach to doing it. It looks weird because it's an infinite loop. Then we're gonna call the renderer, and then we're gonna ask it to render. And for now, we're just gonna break out of the loop immediately so we don't burn off the CPU. So that's sort of the plan. And hopefully this compiles. Yay, it compiles. Great. So what we're gonna do, and this is where it gets interesting because GLES2 doesn't have a fixed function pipeline, so we have to load shaders for everything essentially. So what we're gonna do is we're gonna start with sort of a really, really primitive shader pair. And what we need to do is we need to load them. So we are gonna start this, probably gonna get refactored later. So what we need to do here is we need to have a couple of private components. We're gonna include the GLES headers here. So what we need to do is we need a geo uint for our fragment shader, for our vertex shader, and finally we need one for the shader program, essentially, when we link things together. So starting with this, we are going to start with, say, the vertex shader. So our vertex shader is going to be a geo create shader. This is going to be a GL vertex shader. Now we need to load a shader in. We have this wonderful assets file or assets folder up here, which gets compiled down along with the program, allowing us to access files in that even in the browser. So we're going to create a shaders directory here. And from there, we are going to create a GLSL shader. And we're going to call this base.vert. This is sort of a very, very primitive vertex shader. Now, it's declaring itself as version 120 or 120, which won't work for this. We have to use version 100. Now, this is just really, really primitive. This thing sets the output position of the vertex to be a 4-dimensional vector consisting of a 3-dimensional vector of zeros and a 1. So I would sort of tend to write this as this kind of thing, because that looks more sane to me. But what we'd like to do is we'd actually like to take the vertex from our program. So we're going to go for an attribute which we can assign. We're going to say a 4D vector, and we're going to go for vertex. And then we're just going to assign the position here as vertex. That is sort of the simplest vertex shader, well, not the simplest, but very close to the simplest vertex shader I can come up with. Now we need to load that in. So to do that, we need to read the entire file, and we're just going to use a small utility function to do that, which is just going to be a static function only accessible from here. We might move it to a sort of utility library. It's going to give us a string. We're going to call it read file. We're going to, if I could write today, we're going to give it a string as input, the name of the file. We're just quickly going to include the string header. I'm so looking forward to C++ modules. That will make life a lot easier. I'm missing a colon there. Much better. So what we do here is we create a file stream. We'll call it stream. From name, and then we are going to go for input here. So standard IOS in. At this point, we probably need to include fstream, which apparently makes string redundant, which is always good to know. And then we're going to create a standard iStream buff iterator. Because we're going to work on the stream buffer, we don't want to do weird character conversions or anything else. We just want to read pretty much raw. So we're going to create an iterator pair saying begin works from the beginning of the stream, and end is just default constructed. And then we simply construct a string based on these two iterators. So that should read the entire file. So if we, at this point, sort of output read file, and the file name was shaders /base.vert. And you want me to include IOStream so that I can output stuff here. Better. So if we compile that, And again, you can see we're actually loading this wonderful little Vertex program in here and printing it out. So with that done, we can actually go and create the shader, or load the shader. So we're going to have to do a little bit of a temporary here. So I need to grab the VShader source here. And we're going to say that is the result of reading this file. Then we're going to grab here. We can do GL shader source. So it will ask us which shader do we want to associate the source with. We want to do that with a vertex shader. We want to associate one shader. Then we can give it a string, which is going to be pointer to interesting. So we just need to create a quick little pointer here because apparently it wants to write something back to that as well. So we're going to do the VShader source pointer. This is going to be our VShader source dot C string. There we go. So it can write back to the VShader source pointer here. And you can give it a length, which is optional. So we're just gonna pass in a null pointer here. And we need to declare uconst because we don't want to change the source. So that should, in theory, load the vertex shader. And then we've loaded it, we need to compile it. So we go for compile this vertex shader. And that should essentially do it. Yeah, nice and simple. We can just check if that compiles at least. It compiles and it runs, so it can't be all bad. We can, of course, ask GL if there's been an error by calling the GL get error here. So we run that and we get a GL error of 0, which means success.